Welcome to myprojectbazaar.com. Now we will discuss about the product for area delay power efficient fixed point LMS adaptive filter with low adaptation delay. Next we will see the abstract for the product. The least mean square adaptive filter is the most popular and most widely used adaptive filter, not only because of its simplicity but also because of its satisfactory convenience performance. The direct form of LMS adaptive filter involves a long critical path due to the inner product computation to obtain a filter output. The critical path required to reduce the by pipelined implementation when it exceeds desired sample period. Since a conventional LMS algorithm does not support pipelined implementation because of its recursive behavior, it is modified to the form called the delayed LMS adaptive filter, which allows pipelined implementation of the filter. In this paper, we present a efficient architecture for the implementation of delayed least mean square adaptive filter for achieving lower adaptation delay and area power efficient implementation. We use the novel partial product generation and propose a strategy for the optimized balanced pipeline across the time consuming combination block of the structure. We propose the area power efficient low adaptation delay architecture for fixed point implementation of LMS adaptive filter. We use two novel partial product generation for the efficient implementation, general multiplication and inner product computation by common sub expression sharing. Besides, we have proposed an efficient addition scheme for inner product computation to reduce the adaptation delay significantly in order to achieve the faster convenience performance, and to reduce the critical path to support high input sampling rates. Aside from this, we propose a strategy for optimized balanced pipelining across the time consuming blocks of the structure to reduce the adaptation delay and power consumption. As well, the proposed structure involved significantly less adaptation delay and provided significant saving of ADP and EDP compared to the existing structure. We proposed a fixed point implementation of the proposed architecture and derived the expression for steady state error. We found that steady state MSC mean square adaptive filter obtained from the analytical result matched well with the simulation results. Next, we will see the flow diagram for the product. First, the input bit samples to be given to the delay circuit. The proposed structure for the weighted update block is shown in the flow diagram for the product. It performs the n multiply accumulate operation of the form. The step size mu taken the negative power of the 2 power n realize the multiplication increase and available error only by the shift operation. Each of the MAC unit therefore performs the multiplication of the shifted values of error with the delayed input samples, followed by the additions corresponding to the old weight values, and the n multiplication of the MAC operation are performed by the n partial product generation followed by the n shift add trees. Each of the partial product generation L by 2 partial product corresponding to the product of the recently shift error value. The error value of the number 2-bit digits of the input word signals, where the sub expression shared within the multiplier. Since the scaled error multiplied by the n delayed input values, weighted updated block, the sub expression to be shared across all the multipliers as well. This leads substantial retention of the adder complexity. The final output of the MAC unit decide update weighted to be used as inputs to the error computation block, well as the weighted update block for the next iteration. First, we will see the input samples of the to be given to the delay circuit. The delay unit to be samples bit by bit to be every clock sizes. Then go to the partial product generation block. At the same time, the error bit to be sampled by the delay circuit. The error bit to be three types of error to be given to the partial product generation. One is a direct input, and one more is a shift, and one more shift and add to be applied to the partial product generation block. Then the input bits and the error bits to be added to the adder value go to the shift add tree block. Then the shift add tree method to be multiplied by the shifted and tree the one by one process. Then go to the final output for the delay and add unit. Thus the delay to be add the separate register to be stored by the final output and add the one by one. Then final output samples to be displayed by the output for the product. And finally we will see the output for the product. The VHDL coding for the weighted block of LMS adaptive filter to be run the output for the product. First implementation diagram to be placed with it. Then synthesis the output for the LMS adaptive filter. Then synthesis the process for the LMS adaptive filter. The error and warning to be displayed by this window, and to be run the LMS adaptive filter. Then run the process and finally displayed by the RTL diagram and technological diagram for the given signal. Then completed by the synthesis process. Then go to the view of RTL diagram. Then number of blocks to be displayed by the, then add the RTL diagram, create the schematic RTL diagram for the product. This is the schematic RTL diagram for the product. The inner product of this cell to be displayed by the RTL diagram process. This is the RTL diagram for the given LMS adaptive filter. In every blocks to be consist of this process. Then go to the view technological schematic diagram for the product. Thus the blocks to be displayed. Then add the technological create the technological diagram for the product. Then minimize the circuit to be displayed in all the process of the product for the given LMS adaptive filter. Then go to the simulation process for the LMS adaptive filter. Then simulate the signal for the LMS adaptive filter. The simulation process to be displayed by this signal. Then go to the clock input to be given to the process. Then input signal to be displayed given to the signal. Then input samples to be given by the process. Then error signal to be displayed by this process. Then run the output. Then minimize the signal and view the detailed output for the clock signals. Then clock the then produce the one by one clock signal to be displayed by this process. Then first output to be displayed by the one delay circuit. Then go to the given clock signal for the process of one by one. Then second clock signal to be displayed by this process. In every process to be every separate delay to be applied for the clock circuit. Then produce the every output for the each delay of the clock signal. Finally, we will 4 clock signal to be applied by the process, then displayed by the output for the in every delay of the clock signal to finally produce the output for the weighted blocks of the LMS adaptive filter.